Hello everybody, welcome to the homework help video for 511, problems 6 through 11. So, you should have noticed that number 6 looks just like the warm-up we did in class. If you have any questions, you can look back at your warm-up, or you can ask me in class, but that one you should have in your notebooks already. So moving down to number 7. Number 7, we're dealing with systems of equations, which they want us to solve algebraically and then to check it graphically, using our graphing calculators, or at least that's the method I will be showing you. So in this first one, in part A, we're interested in solving for x and for y in order to determine that point of intersection. So we can see that we've already got one of the equations solved for our variable, solved for x. So what that tells me, and is a big hint, is that we're going to be using the substitution method in part A. What that means is when I see an x in my top equation, I'm going to plug in whatever x was equal to. In this case, that's 3y minus 5 plus y is equal to 3. Again, we know what x is equal to in that second equation, and so we plug it into our first equation. Then we can solve for y by combining our like terms. We've got a 3y and a y, so that gives us a total of 4y's. Minus 5 is equal to 3. We can then add 5 to both sides, and we're left with 4y is equal to 8. We'll divide both sides by 4 to get y by itself, saying that y is equal to 2. Once we know what y is equal to, it's really easy to solve for x. Our bottom equation is already solved for x. It tells us that x is equal to 3y minus 5. So all we're going to do is plug it in, and we see that x is equal to 6 minus 5, so x is equal to 1. That means we're looking for a point of intersection where x is 1 and y is 2. And we're going to check it by graphing it. Now you can graph it by hand or on your graphing calculator. But in either case, what you're going to need to do is get your equations so that they're both solved for y. Let me pull that off. So when we go into our calculator, we need to make sure that these equations are solved for y. That first one we'll have to rewrite so that y is equal to 3 minus x. And then our second equation also has to be rewritten. Careful, that one's got some nasty fractions in it. So we're going to have x plus 5, the quantity x plus 5, and then we had to divide all of that by 3. So make sure you have those parentheses in there. If you do not, it's going to throw your numbers off when you're entering it into a graphing calculator. So we have our two equations. The first one's going to be my blue line, and the second equation is going to be my red line. And we're going to be looking for that point of intersection. So when I graph them, there goes the first equation, and then the red will be our second equation. Looking for that point of intersection, your graphing calculator shows you how to do that. There's a calc function by hitting second and then trace. We're looking for the intersection point, which is option number 5. And then you want to scroll over till you get about where you think that intersection point is for both of the lines. Hit enter 3 times, and it'll show us that our intersection is at the point x equals 1 and y equals 2, which verifies information we saw before. Oops, sorry, I got some extra stuff coming up. And that's what we needed to do in A. B is very similar. Ooh, it keeps coming and going. There we go. B is very similar. We're going to solve our system of equation using substitution. And we'll verify by plotting the points and seeing that they do intersect at a specific point. In part B, you should get an answer of x equals -3 and y equals 2. So our intersection point is -3, 2, which you can check by graphing those equations. If you have any questions about that one, please feel free to come and see me. Moving on. We're looking at 5.8. 5.8 gives us a function and tells us to evaluate it. One of the great things we can do with this is we can put this into our calculators. F of x is just a fancy way of saying y. So we really have the equation y equals 6 divided by 2x minus 3. So I'm going to take that again and put it on our graphing calculator for our y equals. And then I'll take and enter in that equation. So they told us y is equal to 6 divided by, I believe it was 2x plus 3. Or I'm sorry, 2x minus 3. I had to double check that one. If I go to my table, I can see that I've got it starting at 0 and going up by 1. So right now it's set to automatically generate a table for me, which is nice because in A they ask us to find out what happens when x is equal to 1. We can scroll down on our table and see that we're going to get negative 6. So when x is 1, y is negative 6, or f of 1 equals negative 6. For 0, we'll get negative 2. They also ask us for some negative 3, so I'm going to scroll up in my table. We see that negative 3 is equal to negative 0.6 repeating, which as a fraction is just negative 2/3. And they also ask us to do 1.5. So you'll notice that my table does not currently have 1.5. But what I'm going to do is change the setting so that instead of going up by 1, it'll go up by a half each time. That way I'll be able to see 1.5, positive 1.5, on my graphing calculator. And we see that we get an error, which means we're going to be undefined. Let's think about some reasons why we might be getting an error. This kind of calls back to a question that was on your final exam, where it asked you to define the domain of any values that could not be in the domain. If you look at our equation as it is, we've got a denominator of 2x minus 3. And so what happens there is, let me pull up my smartboard. When we have that in the denominator, we know that we cannot ever divide by 0. And so what we want to do is set our denominator, which is our 2x minus 3, equal to 0. And if we solve, we see that we get 2x is equal to 3, divide by 2, x is equal to 3 over 2, which is the same thing as 1.5. And so we can't ever have 1.5 in the denominator, and that's why we're getting that error message on our graphing calculator. All right. New page. Moving on. We're looking at 5.9. It says that Benjamin is talking Algebra 1 and is stuck on the problem shown below. Examine his work so far and help him by showing and explaining the remaining steps. And so he's asked to simplify the expression 3 times a to the negative second times b, and then we're taking and cubing all of that. He does a great job of knowing that when we are cubing something, we're taking everything and multiplying it by itself 3 times. Now what? Well, what we could have done is he does a great job of showing us that we can expand it out. Another way of seeing it is we can take this exponent and distribute it to each of our values. And so we've got 3 cubed times a to the negative 2 times 3 will give us a to the negative 6 times b to the third. When we simplify that, we know that 3 to the third, 3 times 3 times 3 is 27. A to the negative 6 and b cubed. If we want to, we can eliminate a negative sign, which is what we want to do when we want to simplify something. We know that if we've got a negative 6 in the top, what that means is we can take it and pull it to our denominator. So our final answer would be 27 b cubed, all divided by a to the 6th. And that's the answer we were looking for in 5.9. In 5.10, we're asked to simplify each expression below and assume that the denominator in part b is not equal to 0. So it's really important then in b that we cannot have a denominator equal to 0. So that means y can't be equal to 0 ever. All right, so simplifying, we know that when we're multiplying these guys, it can be written as x cubed over x squared to get rid of that negative sign. And what we're really saying is that we've got 3 x's in the numerator, x times x over x times x. And so we can simplify that because we know that x divided by x is just 1. We have x divided by x, which is 1. And so our final answer will be x. In part B, we've got a negative in the denominator. And so what that negative tells me is we can just flip it to its opposite. So right now it's in the denominator. Let's throw it up to the numerator and make it positive. So we've got y to the 5th times y squared, which gives us a total of y to the 7th power. In part C, they want us to get rid of that negative. Be careful. What people are going to want to do, and it's very wrong, is this is not equal to negative 4. Never ever going to be equal to negative 4. Again, what that negative sign tells you is that 4 needs to go into your denominator. And so right now you have 4 to the negative first over 1, and we want to take and bring it down. So we're left with 1 up top and 4 to the bottom. We've got 1 of them. So our answer is just 1/4. A great way, since we've got numbers here and not variables, to check yourself is to plug it into your calculator. If you were to plug 1 to the negative first into your calculator, it would probably give you 0.25 as a decimal, which we know as a fraction is 1/4. Finally, in D, again, it's very much like the problem we had in 5-9. We just want to take and distribute that cubed, and we want to make sure that it goes to everything. So we'll have 4 to the 3rd times x to the 6th. Which when we simplify, let's see, 4 times 4 is 16, and 16 squared should be, I'm going to pull out my calculator just so I give you guys the right number. So if we want to do, let me go to my screen, 16 times 16 is 254, and the reason I did 16 is that's 4 to the 4th. Or sorry, 4 to the 3rd. Oh, that's why. I wanted 4 to the 3rd, not 4 to the 4th. Good catch. So we should get 64 for 4 to the 3rd power. All right, pull my screen back up. So 4 to the 3rd is 64, x to the 6th. All right, and that's our answer for part D. Lastly, you guys had to work on number 11, and number 11 has got some really good stuff. So, it asks us to graph a few things. First, we want to plot the points. 3, -1, so I'm going to go over 3, down 1. That also has us plotting the point 3, 2, over 3, up 2. And also the point 3, 4, over 3, up 4. So it says plot the points and then draw the line that passes through them. And so when I draw my line, it needs to go through these points. To state the coordinates of 2 or more points that lie on the line. Answer this question. What will be true of the coordinates of any point on this line? And so really what they want you to see is that this is the equation where your x has to be equal to 3, or the equation x equals 3. So we can pick any point as long as our x value is 3. So it can be x1, or sorry, 3, 1. We could have 3, -5. We could have 3, 100. We can pick anything as long as we have 3 as our x value. Similarly, they do something in part B, and they ask you to plot the points 5, -1, so we go over 5, down to -1. Plot the points 1, -1, so over 1, down 1. And -3, over to the left 3, down 1. And we want to plot these points as well. When we do that, I'm going to leave it in blue, we get another straight line, but this time the restriction on our equation is that y has to be equal to -1. And then when we choose the points, again, we can pick anything for our x value as long as our y is equal to -1. In part C, it says choose any 3 points on the x-axis. What must the equation of this line be? So what they want you to see is I'm going to plot these points in red, is we're plotting points on the x-axis. Or sorry, the y. So this is our y-axis, what I just scribbled over. We want to plot all of our points as long as they lie on it. So we can pick any point as long as it's on our y-axis. We see that when we connect all of them, it gives us that vertical line. If you remember in green, we had x was equal to 3. Anytime you see a vertical or up and down line, we're looking for an equation where x is equal to something. And what's true about all of these points is that no matter what point we pick, our x value always has to be 0. And so we get the equation that x is equal to 0. Hope this helps you out with your homework. If you have any other questions, please feel free to come see me during ELO or your study hall. I hope you have a great day. All right, and we'll see you.